Authentication methods that we can use on the wireless local area network. Let's begin. Understanding the big picture about Extensible Authentication Protocol, EAP, and 802.1x is really simple if we begin with some basic fundamental components, including some new words that we're going to add to our vocabulary. The big picture of 802.1x starts with the word no. What do you mean, Keith? No. Well, it means that this client right here, let's say it's Bob, and he wants to connect to this access point. The access point says, I'm not going to move any data traffic for you, none whatsoever, until we can prove who you are. And Bob says, you mean you want me to supply my credentials? And the access point says yes. In 802.1x, we'd call this device that's supplying the credentials, we'd call it the supplicant. And most operating systems have a built-in supplicant today with 802.1x, so they can provide those credentials. The access point, who is asking for those credentials, is called the authenticator. So these are the roles, if you will, in 802.1x. We have the supplicant who provides credentials. We have the authenticator who's asking for credentials. So what happens if the supplicant actually provides the credentials? Maybe it's Bob's username and password. What's the access point going to do with it? Well, in an enterprise full-blown 802.1x, we're not going to keep Bob's username and password here at the access point. Instead, we're going to keep Bob's username and password up here on a AAA server, a centralized server that can be used for validating individuals based on a set of credentials, for example, such as a username and password. So this device up here, which has the third role in 802.1x, is the authentication server. And there are several flavors of authentication servers. There's Cisco's ACS product, and they have several different versions of that. Cisco has a product called ISE, I-S-E, the Identity Services Engine. And there's a whole bunch of open solutions too as well. So what happens, Bob's credentials, which have been given to the authenticator, those are going to be passed up to the AAA server, and the protocol between the authenticator and the AAA server is going to use Radius. That's the language of love between the authenticator and the authentication server. So the entire process goes like this. Bob wants to connect. The authenticator says, I need your credentials. The credentials are given. The AP says, hold on a moment. This port is closed. I'm just saying no until we can prove who you are. Those credentials are passed over a Radius connection up to the AAA server. That AAA server then validates, yes, it's Bob and he can come in, or it says no. Now, if the answer is yes, Bob can come in, not only are we going to say yes back to the access point regarding Bob and letting him onto the network, but check this out. The encryption keys that should be used between Bob's machine and the wireless access point, let's call it key X. That key can be handed from that AAA server down to the access point. So the key for Bob's session will be different than the keys for Lois's session or Mary's session or anyone else's session. So this key will be in the memory of Bob's computer, and this key will be in the memory of the access point for the duration of Bob's session. And when Bob logs off and closes this session, that key is gone, and the logical port that Bob was connecting on is no longer open. If Bob reconnects, he'll have to re-go through the authentication process. So the basics of 802.1x are as simple as 1, 2, and 3. And the terminology, I would encourage you to perhaps write that down and become familiar with it. Because when you see those words, you can know right off the bat from the 802.1x side of things exactly which component they're referring to in the authentication process. So I've got a question for you. If somebody walked up to you right now and said, hey, what are the three main players in 802.1x? You could say what? You'd say, well, there's the supplicant who's providing credentials, the authenticator who's asking for those credentials, and the authentication server. Fantastic. Now, the next question we want to use is, what type of authentication do you want to use in this 802.1x environment? And as a framework for providing that authentication, we can use something called EAP. That's the Extensible Authentication Protocol. Now, when EAP was drafted and written up, they knew there's lots of different methods that we can use to authenticate an individual or a computer. We could use usernames and passwords. We can use digital certificates. We can mix and match on both sides. For example, have one side use usernames and passwords and have the other side use a digital certificate. There's lots of possibilities. So with EAP, there's several flavors that we can use of EAP, and it would be based upon several factors: how secure we want it to be, how difficult it is to implement, and there's usually a trade-off. For example, a very, very secure infrastructure is going to take significantly more work to implement, for example, with digital certificates on every single device, than if we just use simple usernames and passwords. So with EAP, I've got 4 different flavors that I'd like you to write out with me regarding EAP. And they are LEAP, and the L is for lightweight. We've got something called FAST, and that's EAP using flexible authentication via secure tunneling. So you can call that EAP fast, or if you're talking about 802.1x, you say we're using fast, they'll know what you mean. There's something called PEAP, which is protected EAP, and then we have something called EAP-TLS. The TLS stands for Transport Layer Security. And inside of number 3, PEAP, it also has a couple flavors, a couple subsets, if you will, of PEAP. But these are the 4 major ones that I would encourage you to be familiar with. With LEAP, it's very easy to set up. There's no digital certificates that have to be deployed at the client or at the server, the Radius server. And the client, for example, Bob, and the authenticator, in this case the AP, and the AAA server, who's acting as the authentication server, there's going to be mutual authentication between the AAA server and Bob. They're both going to validate each other, and that can help Bob avoid being sucked into a rogue AP that can't pass through the credentials to the real AAA server for that validation. Using FAST, what's going to happen is there's going to be several phases and a whole bunch of mathematical calculations that are done behind the scenes. Bob and the AAA server are still going to authenticate each other as the AP plays the middleman to forward the traffic back and forth that needs to go for that authentication to happen. But with FAST, we're going to do it via a secure tunnel. So we're going to logically create this tunnel between Bob and the AAA server. And in this process, there's something called a PAC that's also generated. And that stands for Protected Access Credentials. So EAP Fast uses a PAC, or Protected Access Credentials, as part of its calculations and algorithms and passcodes that it's going to use as part of its process. Now, to use FAST, you have to have a client who's going to go ahead and support that. And fortunately, most of the clients that we use that are supplicants do support EAP Fast. On some, it's a little easier than others, but most are going to support it. Another aspect of FAST is that it does not require us to implement digital certificates at the client or at the Radius server. So these top 2 options do not require installed digital certificates in order for them to function. Now, the reason I mentioned the certificates is because these 2 options right here, they do involve digital certificates. And to really appreciate the magic of how a digital certificate operates, I'd like to take just a moment and chat with you about the public key infrastructure and certificates in general. So with cryptography, we have 2 different types of algorithms. We have asymmetrical and symmetrical. With symmetrical, we're going to use the same key, and that's a really oversimplification, but the same key for encrypting the data and the same key for decrypting it. Symmetrical algorithms include things such as triple DES and AES. Those are all symmetrical encryption algorithms. With asymmetrical, we don't use the same key to lock and unlock or encrypt and decrypt the data. Instead, with asymmetrical, we use something called a key pair. It's 2 keys, different but mathematically working together. Anything that we encrypt with one of the keys, we can decrypt with the other, and vice versa. And these key pairs are often referred to as public, private. So the public key, for example, we could freely distribute, give it to anybody you want. And the private key, we never divulge, we never give that away. So with that, let's use an example that probably a lot of you do every day, and that is you go to do some kind of secure online transaction. So let's say we have a bank right here, and this is us, and here is the big internet in between us, and we open up a browser and we type in HTTP, and hopefully we're doing HTTPS. So we're using some flavor of SSL or transport layer security to build a secure connection to that banking website. Now, it's also very likely if we didn't type in the S, we just did HTTP, hopefully they would redirect us to an HTTPS site, and we connect. And so for the average user, we think, great, I've got a secure HTTPS session. But what's really going on in the background is we are using digital certificates for us to authenticate, to validate that that bank really is who they say they are. And you might be saying, well, Keith, I don't remember making that bank prove who they were. How did that happen? And here's how it happened. It happened with something called a digital certificate. When we connect to the bank via HTTPS, the bank is going to send us its digital certificate. And 2 of the big things about a digital certificate is that it contains So if this is the digital certificate, inside of it, we've got the bank's public key, and the certificate is also signed by someone that we trust. So when the digital certificate is sent down to us, down to our computer, we look at the digital certificate and we say, well, is it signed by someone we trust? And if it is, then we can extract the public key of the bank or that bank's website and use that as part of our cryptography. So I want you to think of this. Whenever you think of a digital certificate, I want you to think this is a public key, meaning this contains some entity's public key. Whether we trust that digital certificate or not depends on whether it's signed by someone that we trust, meaning it was issued to the bank by some entity that we trust. Now, inside of our browsers that we use, they've got a list of trusted certificate authorities, the entities that are issuing these certificates as part of the PKI, the public key infrastructure. So if this bank wants to be able to validate their identity, a long time before we ever connected, they would have gone to this certificate authority like VeriSign or GoDaddy or whoever. They would have requested an identity certificate from that trusted certificate authority. They'll use that certificate as part of their HTTPS configuration on their server. And then in the background, when we connect, they download their cert. We see that it's signed by somebody that our browser trusts. So we go ahead and extract the public key. We believe it to be accurate because we trust the entire certificate. And then we can use that public key to confidentially send information up to the server. So for example, if we have the public key of the bank, we can take some data, which might be the beginnings of some secret shared material that we're going to use. We can encrypt that data with the bank's public key, ship it to them, and they, being the only entity that has the private key, could use the private key, their private key, to decrypt that data and find out what we sent them. And that's how we get the process rolling with an SSL/TLS session between us and the bank. Now the other question is, how does the bank know who we are? Well, the answer is they're going to prompt us for some user authentication, very likely a username and a password, which will all be sent via the secure SSL session. So on this side, we're using a cert for us to validate the bank, and the bank is validating us based on a username and password. So now the big question, how does this apply to our wireless security with flavors of EAP? Well, we have the last two I want to mention and talk about are PEAP, which is Protected Extensible Authentication Protocol. And with PEAP, let's say we have the AAA server here, and we have Bob. And of course, we have the middleman, the authenticator in the middle. And what's going to happen with PEAP is that the AAA server is going to be using a digital certificate, and we are going to use a username and password. So when Bob goes to authenticate, part of that process is he's going to be validating the digital certificate that the AAA server has. And now here's the rub. If this AAA server did not get his digital certificate from somebody in the PKI that this client device already trusts, then the client's going to get a warning saying, oops, warning, we don't trust this certificate. You can continue at your own risk based on the client. And then the customer can make the choice of continuing. Ideally, our users would never continue with a certificate when they got a warning about it, the certificate not being trusted. So that's how we validate using PEAP, the server, because it's got a digital certificate, and then we would put in a username and password. And that's how the server validates us. So it's mutual authentication. We're validating each other. This would also protect us against connecting to a rogue or some other type of access point that wasn't authorized. The other option that uses digital certificates is the EAP-TLS, Transport Layer Security. Except with EAP-TLS, both sides are going to have digital certificates. So we need a certificate on this side, the client side, as well as on the server side, and they would use the digital certificates on both sides to authenticate and validate each other. So we've taken a look at the concept of 802.1x. We've looked at 4 specific flavors of EAP. We did a brief overview of the concept of a public key infrastructure with trusted certificate authorities who are digitally signing certificates that they hand out. And with 2 of our flavors of EAP that we're looking at, we have a server-side certificate with PEAP, and we have a client and server, both sides, with EAP-TLS. I hope this has been informative for you, and I'd like to thank you for viewing.